Alright guys, today we're going to start section 6.9. This is a lengthy section, so this is going to be broken into 3 videos. So we're going to do part of it in this video, and then there'll be 2 other videos. So it'll be 6.9a, b, and c. Alright, so let's get started. There are 4 teams in the women's gymnastics final: Russia, China, USA, and Japan. How many different ways can the gold, silver, and bronze medals be awarded? List all the possibilities. So what we can do is do 4, because there's 4 teams, then there'd be 3 teams, then there'd be 2 teams, then there'd be 1 team. So 4 times 3 times 2 times 1 is 24 ways. Okay? The ice cream stand at the state fair has 4 toppings: sprinkles, fudge, Oreos, and peanuts. You're ordering 3 topping sundae. How many different sundaes can you get? Okay, list all the possibilities. So we could get sprinkles, fudge, Oreos, sprinkles, fudge, peanuts, and fudge, Oreos, peanuts, fudge, or how about this? Not that one. Sprinkles, Oreos, and peanuts. Okay? So it doesn't matter the order here, because if I said Oreos, fudge, and sprinkles, they're all going to be the same on the pizza. Medal count does matter. Okay, so that's why there's more possibilities. So there's 4 possibilities. How are the 2 problems in the warm-up the same? And how are they different? So they're different because the order matters in number 1. It doesn't in number 2. Okay? They are the same in that they had 4 options to order. Okay? They have 4 countries here and 4 toppings there. Okay? So permutation. Okay, so the definition of a permutation is an ordered arrangement of n objects. And it could be people, numbers, letters, etc. Okay. Problem 1 was an example of a permutation. the order of the objects matters. A different order creates a different outcome. And a way to remember this is permutation position matters. All right, so if the order in which you put something matters, then it's a permutation. All right, so example 1. There are 8 people running a race. How many different outcomes for the race are there? So we would do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and that's going to be 40,320 because you have the first person to cross the line, and after that you have 7 people left. Then that person crosses, you have 6 people left, then 5, then 4, so on and so forth. And when you're running a race, the order in which you finish is important. So there will be 40,320 outcomes. Okay? Now, when you're multiplying a descending number of descending natural numbers, a series of them, that's called a factorial. So this would be like 8 factorial. So 5 factorial simply means 5 times 4 times 3 times 2 times 1. Okay? And that's going to be 120. And everybody, it's generally accepted that 0 factorial is just 1. Okay, so if you ever see that, but we don't normally see that. Okay, so how do we do this on the calculator? So this is 20 factorial. Okay, so to do 20 factorial, we type in 20. Let me just clear all that out. 20. Then we go to math. So let's write the steps down first. We're going to go to math over to probability. Then we're going to select, go over to probability. Then we're going to select option 4. Okay, so when we select option 4, it puts that there. And what you're going to see, when you see an E right there, that means like times 10 to the. So it's scientific notation. Okay, so this is really 2.433, and we're just going to leave it as that because this rounds this up to a 3. We'll keep 3 places. Times 10 to the 18th power. So that's a lot of numbers. So you wouldn't want to type in 20 times 19 times 18 times 17 times 16 and so on and so forth. So that keeps us from having to do that. Okay. Now, revisit this race problem from above and change it a little. There are 8 people competing in a race. How many different ways can first, second, and third place medals be awarded? Okay, so what we would do, we had 8 people for first. Then after that, we would have 7. So this is first. This would be second. There would be 7 people to compete for that. And there would be 6 people to compete for third. 8 times 7 times 6 is 336. Now, there is a permutation formula. We're just going to kind of put a box around it here. Where N is the number of things you choose, and R, you choose R of them. So N is the total number of people like you have, like 8. And R would be the 3 in this case. So let's look at this problem. So we're going to redo this using the formula this time. So there are 8 people, and there are 3 places that they're competing for. So we're going to put 8 factorial here over 8 minus 3 factorial. Okay, now what we could do to make this a little simpler we can write out what that factorial means. This right here becomes 5 factorial, right? 8 minus 3 is 5. So this would be 5 times 4 times 3 times 2 times 1. And if you look at this, all of this would cancel out all of this. And you'd be left with what we had at the top, 8 times 7 times 6, which is 336. Now, let's do this next one. 12 skiers are competing in the final round of the Olympic freestyle aerial competition. How many ways can 3 of the skiers finish first, second, and third to win the gold, silver, and bronze? So how many skiers do we have? 12. They're competing for 3 medals. So order is very much important here. So we're going to have 12 factorial over 12 minus 3 factorial. So this is 12 factorial over 9 factorial. So remember down here you've got 9 times 8 times 7 times 6 on down. And here you have 12 times 11 times 10. And then you have the 9 times 8. But that's going to cancel out with this. So you only have to that number. So 12 times 11 times 10 is 1,320 ways. Now, there's an even easier way to do permutations on the calculator. Okay, and it's using math over the probability, option 2. Okay, so we're going to do math over the probability, option 2. Now, if you have a newer calculator, you have blinky boxes here. And if you have an older calculator, which I think this one is dead. That's lovely. Well, if this wasn't dead, you would see you did not have blinky boxes. So what you would have to do is type in, let's say we were going to do this last problem. So 12 to P of 3. So that's how you do it on this calculator. And then you'd hit enter and it'd be 1320. But on the old calculator, you would type in 12 math over the probability, option 2, and then you would hit the 3, and then you would hit enter. Okay, so it doesn't give you blinky boxes. You have to type in the order you want to see it on the screen. Okay, so that's that. Okay, so it's NPR. Okay, so we're going to use the calculator on this one. So everybody get ready to use your calculator. So a relay race team has 4 runners who run different parts of the race. There are 16 students on your track team. How many different ways can your coach select students to compete in the race? Okay, the reason why order is important is because this is a relay team, and so the order in which you run is important. Okay, so our problem is going to be 16P4. So take a minute and type that into your calculator. All right, you should have gotten 43,680. Okay, so hopefully you got that. Let's do one more, and this will be the end of our lesson for today. The school yearbook has an editor-in-chief and an assistant editor. The staff of yearbook has 15 students. How many different ways can the students be chosen for these two positions? Because they have titles, order is important. Okay, so 15P2. Take a minute and type that into your calculator. All right, and that's going to be 210 ways. And that's all we're going to do for today. And the next video will have the next set of notes. Thanks.